Okay, so we have a little lesson here on parallel and perpendicular lines. What are parallel lines? These are parallel lines. Parallel lines never intersect. They're going in the same direction. They have the same steepness, which technically means what? That they have the same slope. So parallel lines have same slope, have the same m value. So if we look at the above blue line, from here to here, you rise 1 and run 2. So the slope is 1/2. Rise 1, run 2, rise 1, run 2. So the slope is 1/2. This guy down here, same deal, rise 1, run 2. The slope is 1/2. So parallel lines have the same slope. We need to memorize that. Parallel lines have the same slope. They never intersect. So we're going to focus more on the algebraic portion of it, where we identify that the m values are identical when we have parallel lines. In geometry, you're going to be looking at the visual, but in algebra, we're focusing in more on the algebraic, that the parallel lines have the same slope. Now, perpendicular lines in geometry, you're going to find out that there are two lines that cross to form a perfect 90-degree angle. Okay, but in algebra, we focus more in on the fact of how the slopes are related to each other. Okay, so let's take a look at this line right here. I'm going to put a dot at the y-intercept. And what is my slope from that green dot? Am I going up or am I going down? Down how many? 1, 2, 3. And then I go over 1, 2. So from that green dot to this green dot, I'm going down 3 over 2. So my slope, my m value, is down 3 over 2. Now, my other line, if I look at the other slope, let me do yellow dots here. From this yellow dot to this yellow dot, I'm not going down 3. I'm going up 2 over 1, 2, 3. So that'd be a positive 2/3. So the m is a positive 2/3. Okay. So parallel lines have the same exact slope. Going back over here, from here to here, you went up 1 over 2. So the slope right there is 1/2. And same deal, if you go from this dot to this dot, it's the same slope, up 1 over 2. So the m equals 1/2 as well. So parallel lines have the same identical slope. What about perpendicular lines? What could you say? Are those identical? No. Anybody see a relationship? What is the relationship? The other one, okay, so this one's negative, that one's positive, and not only that, the fraction flips, right? So how do we say that? We say that perpendicular lines have opposite reciprocal slopes. Okay, opposite reciprocal slopes. This diagram right here will explain that a little better. Check it out. It's the same graph, but we have one line that has positive 2/3 plus 1, right? Cross that 1, you go up 2 over 3. This is the line, y equals 2/3 x plus 1. The slope is 1/2. And this line crosses the y-axis at 4, and you go down 3 over 2. So that's this equation right here. And if you compare the slopes, this one's positive 2/3, this one's negative 3/2. So these lines are perpendicular, and perpendicular lines have slopes that are opposite reciprocal slopes. Opposite reciprocal. This is what we need to know for perpendicular lines. Opposite reciprocal slopes. Okay? So parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. Let's jump into the notes that we just handed out. And before we even start the section of parallel and perpendicular lines, which we already know, just a review of the previous section that you still need to know, very important. Whenever I give you 2 points, label your coordinates x1, y1, x2, y2. And you could use the slope formula to find the slope. And then step 2, once you have a point and the slope that you just found, you could write it in point slope form, right? Where your m goes right here and your x1, y1 goes right there. And then if you need be, you change that point slope form to slope intercept. How? By distributing and then adding. That way you could get y by itself. And once you have y by itself, that's in slope intercept. And last but not least, if you wanted to change it back or change it to standard, you'd subtract this x term and subtract that x term, and you'd rewrite it in standard form. That's a review of the previous section, but we're not on the previous section right now. We're going to continue with parallel and perpendicular lines. So again, we need to have this memorized, everybody. that parallel lines have the same m value. They have the same slope. Parallel lines have the same slope, okay? And these are all examples of equations that are parallel, of lines that are parallel. Now, the only way you could tell the slope is if they're either in slope-intercept form or point-slope form, okay? So in order for you to see that blue M or that blue M, they have to be organized like this, either y by itself, y equals mx plus b, or point-slope form where you could clearly see the M. Standard form won't help you find the M. If it's in standard form, you're going to have to change it to slope-intercept so you could actually see the M. So it's very important that we are comfortable with the different forms and that we know that you could only see the slope if it's in slope-intercept form or point-slope form. Anyways, with that said, we can now look at these examples. All of these examples are lines that are parallel. They're the first two, they're both in slope-intercept form, so we could clearly see that the slope is 2/3, the slope is 2/3. That means that these guys are parallel. If you were to graph them, they're never going to cross, okay? Now, number two, the slope right here is -2. However, you cannot look at this slope yet because it's not in slope-intercept form. You don't want a negative y, you want y equals mx plus b. So you're going to have to do some algebra to be able to check the slope. So we're going to have to divide or multiply everything by -1. In other words, you're going to change all the signs. And now you could see that the slope is -2, which is identical to this slope. Okay, so once again, parallel lines have the same slope. Okay, you know what? Do me a favor. Turn to somebody right now and tell them parallel lines have the same m value. Okay. That's right. Okay. Okay, so parallel lines have the same m value. Okay. So if we look at number 3, are those parallel? Yes, they're parallel. Why? Because they're both in point slope form, and we could clearly see that slope is 1/2 and that slope is 1/2. The last one, this slope is 1/2. This other slope you can't see yet because it's not in any form. You have to get y by itself first. So divide by 2, divide by 2, divide by 2. Y equals, there's an invisible 1 in front of the x, so y equals 1/2 x minus 7. Now you could see the slope on the second equation. The slope is 1/2, just like this one is. So that means that they're parallel. So all of these were examples of parallel lines, okay? Up here, we're going to talk about perpendicular lines. And we already mentioned that perpendicular lines intersect each other to form 90-degree angles. They form perfect corners. But more importantly, in algebra, perpendicular lines have opposite reciprocal m values. So what the heck does that mean? That means that you change the sign and flip the fraction, okay? So if we look at this first one, what is the slope of the first equation? The slope is 2/3. Now, pretend I can't see, well, let me see. Pretend I can't see this guy yet. If I wanted a perpendicular slope, I would change the sign and flip the fraction, which means that what's a perpendicular slope to 2/3? -3/2. -3/2. And you could see it right there. You see, these are perpendicular slopes, -3/2. Again, it's opposite reciprocal. Change the sign, flip the fraction. That's how you get a perpendicular slope. So all of these are examples of lines that are perpendicular to each other. So for example, this guy right here, the slope is -2 because it's in y equals mx plus b. I could see the slope is -2. And if I wanted the perpendicular slope, I would change the sign and flip the fraction. So technically that's over 1. It doesn't look like a fraction, but I could put it over 1. So if I change the sign, it becomes positive. And if I flip the fraction, it'll become 1/2. So that's why these guys are perpendicular, okay? So again, the main point here is perpendicular lines have opposite reciprocal slopes. Turn to somebody and tell them, perpendicular lines have opposite reciprocal slopes. Go. Okay, and also explain to them what the heck opposite reciprocal means. It means that you change the sign and flip the fraction. All right, great. So looking at number 3 has both equations in point slope form, not slope intercept. So I could look at the slope right here. It's -1/3. and I could look at the slope over here, and those are opposite reciprocal slopes. If I change this to a plus and then flip it, it'll be a positive 3 over 1, which is just positive 3. Okay. The last one right here, the slope is 3/2, but this other one is not in point slope form, and it's not even in slope intercept form. So I need to get in slope intercept form so I can see the slope. So I'm going to divide by -3, divide by -3, divide by -3. Then I'll have y equals negative 2/3 x plus 4. And now we could compare the slope of 3/2 compared to negative 2/3. And those are opposite reciprocal slopes. Change the sign, flip the fraction, it'll become negative 2/3. So those are all examples of perpendicular lines. So this is what you're going to see on the next test. It's going to be on there, where I give you two equations and I ask you, are they parallel, are they perpendicular, or are they neither parallel nor perpendicular, right? So all you got to do is first make sure that you could see the m value. If you don't have y by itself, you cannot see the m value. See, this guy's in standard form. Standard form doesn't have an m value. This guy doesn't have y by itself. You cannot see the m value. So you got to first make sure that you can see the m value. And then once you compare them, if they're the same exact slope, they're parallel. If they're opposite reciprocal slopes, they're perpendicular. And if it's obviously neither of those, then you would say neither. Okay. So number one, would you guys say that these slopes make the lines parallel, perpendicular, or neither? See, they both have y by itself, so you could see the slope. This slope is 1/2. This is -2. Are they identical? No, so for sure they're not parallel, because parallel lines have the same slope. They'd be identical. But are they opposite reciprocal slopes? You see how this is a positive 1/2? If I change it to a negative and then flip it, change the sign, flip the fraction, what's it going to say? It's going to say -2 over 1, which is just -2, and that's what it says. So these, for sure, are perpendicular. Perpendicular. So everybody label that. Now the next one, I can't see the slope. I can see the slope on this one because it's in point slope form, but I can't see the slope on this one yet because I have to divide everything by -3 first to be able to see it. And we know that there's an invisible 1 right in front of the x. So what I have here, that cancels out. I have y equals -1/3 x minus, no, not minus. I'm sorry, this should have been a division bar. So that'd be plus 8/3. But all we care about is the slope. And the slope here is -1/3 in front of the x. And if you compare that -1/3 to this 3/2, are they identical? No, so they're not parallel. Are they opposite reciprocals? No, they're not. So right here you would say neither. Neither. Okay. Moving on to the next one. What is the slope of this guy? What's the fraction in front of x? 1 over 1, right? And what's the fraction over here in front of x? -1 over 1, right? So now we could see the m values. So are they identical? Are they identical? No, so they're not parallel. Are they opposite reciprocal slopes? If you change that to a negative and then flip the ones, it's going to be a -1 over 1. So those are opposite reciprocal slopes. So this would be called perpendicular. Number 5. You know what? Number 5, I don't like it. Let's do something different right now. Go ahead and change this 15, change it to a 21. Okay, and I'll tell you why in a little bit. But change to a 21, and now let's look at the slopes. Well, this one's in y equals mx plus b. The slope is 2/3. That's the m value. This one's not in slope intercept form. You got to get y by itself first to be able to get in. Well, you got to get y by itself to be able to see the slope. So divide by 3, divide by 3, divide by 3. So you're going to have y equals 2/3 x plus 7. And now we could compare the slope 2/3 with the slope 2/3. So what do we say? Parallel, perpendicular, or neither? Parallel. Same slope. Okay. Now, the reason why I made you change a 15 to a 21, because if you would have left it 15, you would have ended up with y equals 2/3 x. 15 divided by 3 is 5. And a lot of people would see that they're the same exact slope, 2/3 and 2/3, but that would be a 5 and that's a 5. So you wouldn't, I mean, it's kind of like a trick question. You do have the same slope, but you have the same slope not because they were parallel, but because it was the same exact line. So that's why I made you change the 15 to a 21. That way we don't get confused. These are different equations with the same slope. Those are parallel. Last but not least, these guys, number 6, they are perpendicular. And why is that? Because you got to get rid of the minus sign in front of the y. So divide by -1, divide by -1. There's an invisible 1 in front. So you really have y equals -1 over 1x. And the other one's y equals positive 1 over 1x. And these are opposite reciprocal slopes. The negative changes to a positive, and if you flip it, it'll say positive 1 over 1. That's what it says. These are perpendicular. I'll just abbreviate. Didn't fit. Anyway, that's what you need to learn for today, that parallel lines, they have the same slope. Parallel lines have the same slope. Perpendicular lines, let me highlight this in red. Perpendicular lines have opposite reciprocal m values. What does that mean? You change a sign and flip the fraction. Okay. Now, how's this going to play out in the future? So far, I've been giving you like 2 points and you find the slope, and then you use the point and the slope to write it in point slope form or something like that. But we're going to have questions like what we see right here on this worksheet. It says, write an equation in points in slope-intercept form of the line that passes through the given point and is parallel to the graph of the given equation, okay? So they are telling you that they are giving you a point. So like right here, there's a point, and they're also telling you that your line is going to be parallel to the graph of the line of the given equation. So if your line is parallel to this line, they are indirectly telling you your slope, because parallel means same slope. So if your line is parallel to this guy, that means that your equation has a slope 3. Okay, so if they tell you it's parallel, now you don't have this worksheet yet, we're going to actually work on this tomorrow, but if they're telling you that your equation is parallel to this one, you're just going to pull out this m, and that's all you need from that given information. So they're still giving you a point, which is an x1, y1, and they're giving you a slope indirectly because they're telling you it's parallel. So if you have a point and you have a slope, you could now write it in point slope form, right? And we'll practice that tomorrow. I just want to give you a little taste of it right now. So how are we going to use the words parallel and perpendicular? It's an indirect way of providing you the slope that you need to write your equation. So again, if I tell you your line's parallel to this one, it's going to have the identical slope. Now, on tomorrow's worksheet, on the second half, they want you to write an equation of the line that passed through the given point and is perpendicular. So if you know the given point and you know your line's perpendicular to the one that they give you, well, here's the point that they give you, x1, y1, but they tell you that your line is going to be perpendicular to this one. So perpendicular means what? Opposite reciprocal. So you're going to be able to find the m value after you are able to see the m value here, and then after you do the opposite reciprocal of that m value that you see. So perpendicular means opposite reciprocal. So you change the sign, flip the fraction. Sorry about those horrible notes. But anyways, I can't even see the slope here. I want to first start by getting y by itself so I could see the slope. So you're going to subtract x. You're going to have 3y equals negative x plus 6. Then you're going to divide by 3, divide by 3, divide by 3. You're going to have y equals, there's an invisible 1 in front of the x, so you have a negative 1/3 x plus 2. So all you did was you took this equation and you rewrote it in slope-intercept form. Why? So we could identify the slope. And why do we want to identify the slope of this line? Because ours is going to be perpendicular to that one. So what is our slope going to be? If this slope is negative 1/3, what's our slope going to be if it's perpendicular to this one? opposite reciprocal. Yeah, positive 3 over 1, which is just 3, right? So after you do that work, you don't even have to worry about this anymore. You just derived your perpendicular slope. And now you could write it in point slope form, which is y minus y1 equals m parentheses x minus x1. And when you write it in blank spots the way I just did. And of course, plug in your m value of 3 that you derived from this, knowing that they're perpendicular. Plug in your y1 of negative 6 right there, your x1 of negative 1 right there. And of course, you change the signs. And there's your point slope form equation. I think that's what they're asking for, point slope form. But even if they ask for a different form, you start out with this. So let's say they ask you for slope intercept, distribute the 3, subtract the 6, then it'll be in slope intercept. And from slope intercept to standard, all you have to do is move the x back over to the left side. Anyways, I hope this helps. We're going to continue with this worksheet tomorrow. We're going to do this worksheet tomorrow.